What's good, everyone? Today we're going to go over that topic and we're going to use that example. And as always, make sure that you pay attention in class, pay attention to your teacher. If you don't understand what they're talking about, you can always come here and take a look at this topic and make sure to do your homework. I know it's difficult right now, and that's why you're probably watching my video. But you do your work, I'm sure you can get it. This is not a very difficult topic. All right, enjoy, and if you find it helpful, please subscribe. It'll be helpful for me. This example, the first thing that I want you to note here is that make sure you have some prerequisite knowledge. For example, here, you look at this portion right here, make sure you know that a, b, and c, ax squared plus bx squared minus c, where the a is just the coefficient, right? That's the value 1. That's what we have. A is 1. B is 6, and C is that constant, which is -4. We'll need that knowledge in just a bit. But right now, to complete the square, here you have to do some basic steps here. I would recommend that when you're doing this, do it in one specific way. There are several ways to do this. Your teacher might be showing it a different way, but I find this way to be the easiest way. And when I do homework or when I teach students how to do this, I typically ask that student do this in one way and they get really good at it so that when you're doing the test, when you're doing your test, you don't have several ways to confuse yourself and not do so well on the test. So what I typically do here is I want to set this equal to 0. -4 equal to 0. The first thing I always do is to get that constant to be by itself, okay? This way it will be easy for me to just deal with that area alone instead of dealing with the constant as well. So I add the 4 to each side here so I can give the function balance. So then I would have x squared plus 6x equal to a +4. Now note here that to complete the square, what you're going to need to do is you're going to add a specific value here, and to keep the function balanced, you have to also add the same exact value on the right side. So I can see here, if I do that, then if I subtract this box and then subtract this box, you see, now the function is back to what the original function is. We're not really changing the function, we're changing the format of how it is written. So what goes in this box is very simple, and again, we got to refer back to that knowledge. So what goes in that box is b divided by 2 squared. And obviously that should also go in that box, that specific value. So in this case, as you can see here, b is 6. So therefore, in this box, what we'll need is 6 divided by 2, and we'll need to square that. Here, same thing, we'll need 6 divided by 2 squared. In this case, once I get to this step, what I want to do is just open a parenthesis, and I would go x, and this value right here, you see, will just transfer down. So it's 6 divided by 2 will yield 3. So therefore, I just put plus 3. Okay? And that's where it's from. And then what we want to do in this case is square that. Now on the right side, all we need to do is compute these value out. 6 divided by 2 is 3, and we square it, we'll get 9. So then we get 4 plus 9 will give me 13 here. So then my function now can be written as x plus 3 squared equal to 13. Now here, what we want to do now is subtract 13 on each side. So we're going to end up with x plus 3 squared minus 13 equals to your function, which is f of x. And so if you note here, this function is just written in a different way. It is no different than the original function of x squared plus 6x minus 4. If I were to FOIL this out and subtract 13, I will end up with x squared plus 6x minus 4. Now, what is the purpose of changing this into or completing the square? Now that for completing the square, there's a couple of purposes. When we get into this form of y equal to a x minus h squared plus k, when we complete the square, it will be helpful for us to solve for any x-intercept or solutions without using the quadratic formula or factoring the function itself. If you have it in this form, solving for the x-intercepts will be really fast. Finding the vertex quickly, because namely the vertex can be found with that for the x-coordinate, and this is your y-coordinate. Finding the inverse of a parabola will also require that you complete the square, but that's a slightly different topic to find the inverse of a function.